Hi everyone. So today's topic is Euclid's geometry. Have you heard the word Euclid's geometry? Guys? Imran Tamilchelvan? No? Yes or no?
No, ma'am.
No. Actually, Euclid is the name of a mathematician. He developed some axioms, postulates regarding that how to do the sums. That is what we are going to see. Okay. Okay, then I'll be sharing my screen. So before going to, we need to do some discussion. What are the discussion? Euclid's approach to geometry. What is Euclid's approach to geometry? Introduction. The topic is introduction to Euclid's geometry. Okay. So in this, what we are going to learn, what is his approach, Euclid's approach. Okay, now we've seen. According to Euclid, Euclid is the name of a mathematician. According to him, a solid is a three-dimensional figure having shape, size, position, and can be moved from one place to another. Yes, guys, can anybody name some solid shapes? Yes, Imran? What are the solid figures you know?
Curved and straight.
Solid figures. What are solid figures? Tamil children?
Ma'am.
Yes. Name a solid figure.
Square.
Square is a solid. Solid means what?
Sorry, ma'am.
Solids means sphere. Sphere na sphere, it's a ball. Cube. That cube. Cube is a solid. Cuboid, it's a box. These are all solid figures. 3D figures, we can either ways you say. 3D figures, 3D, D means dimensional, 3 dimensions. 3-dimensional figures or solid figures. Okay, I'll give some standard solid figures. Cube. What is a cube? You can see all sides are equal, all my measurements are solid. The cube is a solid figure. Okay, what is cuboid?
Opposites equal, ma'am.
Equal, opposites. It's a, in Tamil we say Ganasivigam, like a shoe box. These are all solid figures. Even book is a shape of a solid, it's a cuboid, isn't it? Cube, now you would have learned playing cube. That's a cube, isn't it? Cube. And cylinder, this is a solid figure. Sphere, this is not circle, this is sphere. Ball, lemon, it's a spherical in shape. Solid figure. Cone, cone is a solid. Okay. Cone is so these are some solid figures. We have numerous figures, but I mentioned a few of solid figures. So according to Euclid, what he's coming to say, a solid is a 3-dimensional figure. That is what 3D. I have written 3D. 3-dimensional figure having shape. Or shape irka or size irka. Shape, size, and position. It can be moved. And the solid we can move that solid. Yeah. So this is what solid. and boundaries of solids are called surfaces. அதாவது இப்போ வந்து solid இது என்னன்னு சொல்றோம், wait, I'll show you. Water, if you draw a cube, இதெல்லாம் இருக்கு இல்லையா, இதுதான் நம்ம என்னன்னு சொல்றோம், surfaces. இது பேரு வந்து என்னது, what is the name of this one is called surface. Yes, this is surface. This is surface. Okay, then in the surface oda boundary இருக்கு இல்லையா, அப்ப this is surface, in the surface oda boundary, அது பேர் என்னன்னு சொல்றோம், the name of the boundaries of the surface is called edges. The name of this one is called edges. Okay, in the edges they meet at a point இல்லையா, the edges எங்க meet பண்ண, they meet at a point. The edges it meet at a point இல்லையா. So these points are called singular is vertex, plurally we can say vertices. Okay, இது பேரு தான் vertices. இது வந்து cube. Okay, if you take a cuboid, okay, இப்போ வந்து ஒரு சின்ன discussion. If you take a cube, how many surfaces are there? Yes, Imran, you think about, you imagine a cube and count this number of surfaces and tell me number of surfaces. எத்தனை surface இருக்கு? How many surfaces are there?
6 surfaces.
Super, very good. 6 surfaces. Okay, number of edges. Edges எத்தனை இருக்கு?
8 edges, ma'am.
8 edges. Are you sure? I don't think so. Are you sure? See, இது மேல வந்து டாப்ல 4 edges ஆ, டாப்ல 4 edges ஆ, பாட்டம்ல அதே மாதிரி ஒரு 4 edges இருக்குமா, we will have a bottom.
Sorry, ma'am.
சொல்லுங்க சார். 4 edges, 4 plus 4 8. அதுக்கப்புறம் what about this? This also edges, isn't it? இது 4. Okay, so totally 12 edges. Okay, 12 edges. Okay, number of vertices. How many vertices? Yes, what happened? Yes, Shatri, tell me how many vertices are there?
Ma'am, 8 vertices.
Very good, very good. There are 8 vertices. Okay, that's it. Okay, now we will discuss some solids. I hope you are clear with this. Okay. Okay, then that's it. Enough with this. Then okay, now we know some mathematical definitions that we will discuss. Okay, guys, before we're going to discuss that, you just write this head topic and make a note of this. Yes, go ahead. Once done, let me know. See, guys, if you copy it, let me know. Copied, guys?
No, ma'am.
Yes, ma'am.
Okay, okay. See, if you copied, raise your hand. You know that option, right? If you done, raise your hand.
Okay.
Okay. Okay. So next, Tamil children. Okay, you can copy afterwards. So next is what? Some of other assumptions. What do you mean by assumptions? Yes? Anybody? Assumptions means what? We are thinking, okay, this is true. Some assume. We are thinking ourselves it is true. That is called assumptions. Okay, some assumptions or some definitions listed by Euclid's or. A point is that which has no part. See, if you put a point, is there any part? Can you measure it? Can you do anything? What is the use of a point? Anybody can say?
It covers 360-degree.
Okay. So it helps to fix a position in a graph sheet or something. You can fix a position of you can denote a position of a particular thing. Okay, that's it. Point. Point has no part. Okay. Line is a breadthless length. Yes, there is no breadth. Only length you can measure for line. Only length is there. There is no breadth. Isn't it? Thickness we don't mean. Okay, surface. Surface is that which has length and breadth only. So surface, if you take a rectangle, there is a length and breadth, then it is called a surface. Actually, all 2D figures are a different shaped surfaces. Okay, that's it. Ends of a line. So if you draw a line, ends of a lines are points. We draw a line segment by end by points. Edges of a surface, the edges of a surface or lines. What are the edges? These are all called edges. These are all called edges. Edges of a surface. Okay. Or lines. Edges of the surfaces are called lines. These are all called edges. Edges. Whereas, what about this? What about this? Anybody? See, if you take a rectangle, this is a rectangle. All you know, rectangle. And what about this? See, guys, what about this? Surface. Very good. Very good. So this is called surface. Surface. Okay. Then, what about this? The orange
Length.
color lines.
Length, ma'am.
No, no. Anybody else? Edges. This is called edges. Okay, edge. This is called edge. There are 4 edges in a rectangle. Okay. Then, what about this?
Vertices.
Vertices or corner. Either way you can say. So singular is vertex. Plurally we say vertices. Vertices or corner or vertex. And plural, we can say vertices. Vertices not plural, singular vertex. That's it. Okay. Okay. Then edges of a surface we have seen. Straight line. Straight line is a line which lies evenly with the points on itself. Okay. Okay. Plane surface. This is a plane surface, isn't it? This is a plane surface. This is a plane surface. That's it. Okay.
Yes, ma'am.
No, that's it. Okay, guys, you make a note of these points and we will move to next concept. Guys, feel comfortable with me. If you don't understand what I am saying, please ask me, okay? Don't keep mum.
Yes.
Okay,
Yes,
dear.
ma'am.
Have you copied?
No, ma'am.
Okay, fine. Make it fast. Seshatri, Tamil Selvan, Imran. Am I right? Or some of your original name is different?
Ma'am, my name is Tamil Selvan, ma'am.
Who is Tamil Selvan? The name written Tamil Selvan. Please, can you come on video? Then you can turn it off if you wish.
Okay, ma'am.
Okay, all are in phone only, isn't it? Okay, so
Rehan, ma'am.
okay, tell me, who is Tamil Selvan? Raise your hand. Okay, you are Tamil Selvan. Okay, then. Okay,
Ma'am,
put
my
down
name
your.
is Mohammed Rehan, ma'am.
Who is that?
Rehan, ma'am.
Rehan, not
ma'am.
Imran. Rehan.
No, ma'am.
What is the spelling?
Brother
Tell
name
me
is,
the.
ma'am.
Okay, okay,
Rehan, ma'am.
that's what. Rehan. Am I right?
Yes, ma'am.
Okay. Then this one, Seshatri. Who is Seshatri?
I am, ma'am.
Okay, your name is Seshatri. Okay. Tamil Selvan. Okay, all are in mobile phone. But are you comfortable with the screen and handwriting and all? Can you view it properly?
Yes,
Yes,
ma'am.
ma'am.
Yes,
Okay,
ma'am.
okay. All have copied. Shall we move on?
Okay,
Yes.
ma'am.
Okay.
Yes,
Okay,
ma'am.
fine.
Ma'am, your voice is breaking sometimes.
Oh, really? I don't know, dear. I don't know what's the reason. Now is fine, right? Okay. Hello. What about?
Ma'am, your voice is breaking sometimes, ma'am.
Okay. I don't know what is the issue. But
It's okay for me, ma'am.
for you, it's okay. I don't know. Somebody's okay. Then next. Now, if you see this, some assumptions and properties which were not proved treated as universal truths. Okay. Universal truths reference to the geometry were termed as postulates. See, some we can't prove, some facts we can't prove, but we trust. Okay, that is true. Related to that truth, related to geometry are called postulates. Related to mathematics are called or termed as axioms. See, what is the meaning of postulates and axioms? Postulates. What is postulates? Some universal truth it is just believed, not proved, not proven or proved, related to geometry or called postulates. Similarly, axioms. What are axioms? Axiom means similarly some universal truths related to mathematics. Or called axioms. Make a note of it. Not this one, this one. You make a note of these two are out. Definition for postulates and definition for axioms. Yes. Okay, Imran, Rehan has copied. What about Seshatri? Don't copy this one. Axioms I'll explain, then you can copy, not now. Only you copy these 2 points. What does it mean? Postulates and what does it mean? Axioms. That's it. Rehan, shall we move?
Yes, ma'am.
Okay, okay. Now, next. See, what are the axioms are there? What does it mean? That is what we are going to see. Now, if you see, some of Euclid's axioms. Euclid's, what are the axioms? Things which are, first one, things which are equal to the same thing or equal to one another. That is, for example, that is, it is given. If A is equal to C and B is equal to C, then A is equal to B. Okay. For example, how do I give? I'll give an example for first postulate. I'll give example. I'm saying P is equal to A and Q is equal to A. From these 2 statements, you can say P is equal to Q, isn't it? Yes or no? For example, now உங்களுக்கு சொல்ற மாதிரி சொல்றேன். Sir, okay, otherwise, how do I say? Yeah, that's okay. Okay, P is equal to A and Q is equal to A. So P is equal to Q. Other than என்ன சொல்றான்? Seshatri Agasthiya ஸ்கூல்ல படிக்கிறான். ரேஹான் அகஸ்தியர் ஸ்கூல்ல படிக்கிறான். நம்ம என்ன சொல்லலாம்? 2 பேரும் அகஸ்தியர் ஸ்கூல்ல படிக்கிறாங்க. அப்படி சொல்லலாம் இல்லையா? That is what? So this is we are saying separately and we can put together. That's it. Okay, second. What is second axiom? If equals are added to equals, the wholes are equal. Second, the equals are added to equals, the wholes are equal. For example, A is equal to B. It is given if A is equal to B, it is given. Okay. I am adding C either side. I'm adding C. What happened? Your left hand side becomes A plus C. Right hand side becomes it is A, B plus C. Both are equal. A plus B, then A is equal to B, then A plus B, A plus C is equal to B plus C. For example, I'm saying 5 is equal to 5. I add 3 equals. If 2 are equals are added, then what? The wholes, what is the result? That is also equal again. That is what the axiom is saying. Equals are, if equals are added to equals are added to equals, then the wholes are equal. That's it. That is what second axiom says. Third axiom. If equals are subtracted from equals, the remainders are equal. See, similarly, A, this is third one. A is equal to B. Yes, equals. These two are equals. Subtracted equals. Then the remainders are equal. Okay, for example, 5 is equal to 5. Equals are subtracted. What is remainder? 2 is remainder. Here also 2. The remainders are also equal. This is what axiom 3 is saying. Okay. And axiom 4. What is axiom 4?
Things which coincide with one another.
Coincide. Things which coincide with one another or equal to one another. For example, there is a line. This is fourth one. There is a line. A, B, C. AB plus BC is equal to AC. For AB and BC, see, AB and BC, this is a common point. It is coinciding, right? That is what they're saying. Things which coincide, here coincide with one another or equal to one another. Okay. So AB plus BC is equal to AC. Then the fifth one, the whole is greater than a part. Okay. What is, how do you mention it? You take a pizza. There is a pizza. From pizza, you are taking a part of it. Always the fullest, this is whole. This is called whole, isn't it? The whole is always greater than the part, isn't it? That is what this one it says. Okay, that's it. And sixth one, what is sixth one? It says things which are double, the same things are equal to one another. Okay, sixth one. A is equal to B. I multiply double. When it will become double? Multiplying by 2, isn't it? So I multiplied by 2. 2B is equal to 2A is equal to 2B. That's it. For example, 5 is equal to 5 multiplied by 2 to make it double. Again, 10 is equal to 10, isn't it? Huh? Isn't it, guys?
Yes, ma'am.
That's it. Similarly, seventh one. What seventh one says?
Things which are always
Halves of the same things are equal to one another. For example, A is equal to B. When it becomes half, divided by 2, isn't it? I divided by 2. Again, the both are equal. A by 2. For example, I take 4 is equal to 4 divided by 2. What it comes to? 2 is equal to 2, isn't it? That's it. This is what the following axioms meaning. Make a note of it. With an example, write one axiom, the corresponding example. That way you make a note of it. Okay. This symbol, it denotes greater. That you know, right? This is greater than. Hmm?
Yes, ma'am.
Okay, that's good. Okay, dear. So once you copy it, let me know. Okay. Rehan has copied. Okay. Next. Next, postulates. Okay. What are postulates? You would have written definition, right? Tell me. What are postulates? See the definition and tell me.
Not true related to geometry.
Okay. It's a universal truth, but not proven. It is not proved. So related to geometry are called postulates. Correct. Okay. Postulate 1. Straight line may be drawn from any one point to any other point. Any one point to any other point. You can draw a straight line, right? That's it. Postulate 2. A terminated line can be produced indefinitely on either side. Yes, terminated line is what? The line is ended, but if you wish, you can extend, right? That's it. Either side, you can extend it. That's it. Postulate 3. A circle can be drawn with any radius and any center. Of course, with any, wherever you want to draw a circle, you can put a center. Whatever radius you want, you can draw a circle, isn't it? That's it. Okay, all right angles are equal to one another. Any right angle, the measure will be whatever protractor you use, that 90 degree is always 90 degree, right? That's it. Postulate 5. If a straight line falling on two straight lines, see there is a two straight lines. This is a one straight line. This is another straight line. There is a one straight line falling on these two straight lines. Okay. L3 falling on L1 and L2. That it means if a straight line, that is L3, if a straight line falling on two straight lines, that is L1 and L2, makes the interior angles on the same side it taken together. If you same side, make the interior angles. If you consider the interior angles, consider the interior angles, lines makes the interior angles on the same side of one side of it together. If you add this and this, I name it as 1 and 2, angle 1 and angle 2. If you taken together, less than 2 right angles. Less than 2 right angles means what is the measure? One right angle is how much?
90 degree.
Two right angles?
180 degree.
So less than 180 means less than 2 right angles, then 2 straight line, if produced indefinitely, meet on that side. See, if you extend these two lines, if the sum of these two, actually the name of these two angles are co-interior angles. If you add these two angles, if it is less than 180 degree, and if you extend, they definitely meet at a point. They definitely meet at some point. That is what they are coming to say. If they are greater than 180 degree, what is the thing? Anybody?
It is parallel.
No. They are diverging. Okay. If you extend, they are diverging. Diverging, you know the meaning? Diverging. They are diverging. If it is greater than 180 degree, they are diverging. If it is less than 180 degree, they are converging and they meet at a point. Okay. Okay. If they are equal to 180 degree, Seshatri.
Ma'am, it constantly moves.
Exactly. You can say the lines are parallel. Okay, only that case if the two lines are parallel and this is a line, and if you consider the co-interior angles, I name it as A and B. If angle A plus angle B is equal to 180 degree, then which implies I name it as L1, L2. The lines are parallel. L1 is parallel to L2. So from this itself, you can conclude the lines are whether parallel or not. If co-interior angle is equal to 180 degree, the lines are parallel. If co-interior angle is sum of co-interior angles is not equal to 180 degree, they are not parallel. If it is less than 180 degree, if you produce them, they meet at a point. If it is greater than 180 degree, they are diverging. Okay, they are diverging. Okay, then what else? That's it. Okay, make a note of this. With this axioms and postulates, we are going to prove some sums. That's it, dear. There are some 10 sums. If you forgot, you'll be fine. How to, using this axioms and postulate, how to we prove? That is what we are going to see. Yes, Rehan, have you copied?
Yes, ma'am.
What about Seshatri?
I also written.
Okay. Okay, now we'll see the sum. What is given in the sum? P, Q, R are 3 points on a line. P, Q, R or 3 points on a line. See, guys, when a sum is given, try to picturize. You will have a better understanding. So there is a line. There is a line. In that line, there are 3 points. I name them P, Q, R. Okay, then Q lies between P and R. Yes. Then prove that PQ plus QR is equal to PR. Yes, guys, what is the idea? We'll go back. There we see axiom. What is axiom? The fourth axiom. You see the fourth axiom? Things which coincide with one another or equal to one another. Okay, So that is what by axiom 4 or by axiom, you can write this axiom or simply you can write. Okay. So here, if you see Q is coinciding, isn't it? And this Q is coinciding. So this must be equal to this. How do you write things by axiom? By axiom 4, things which coincide with one another or equal to, coincide with other or equal to other or equal to one another. Therefore, PQ plus QR is equal to PR. In this, Q, the point Q is coinciding. That's it. So this is the way. So there is no calculation, nothing. So you have to memorize all the axioms and postulates. So to prove this kind of sums, you have to write the axiom and you have to say the result. So you should know how to prove this kind of sums. Make a note of it. Write the question, then solution. That way you do, okay?
Yes, ma'am.
Okay. Next theorem. Two distinct lines. Two distinct lines means two different lines. Cannot have more than one point in common. For example, if they don't meet, if two lines are meeting, whatever the case, see if they don't meet, if the lines line 1 and line 2, if they don't meet, they don't have any common point at all. But if they meet, what are the options? If they meet two lines, they meet only one common point. It can't have more than. If they may meet or they may intersect. They may intersect. Line 1 is intersecting line 2. They can have only one common point, isn't it? That's it. So this we can't write any definition. You just draw the figure. According to the figure, if the lines are not meeting, they don't have any common point. If the lines meet, they can have only one common point. That's it. By the figure, you just write this way. Okay? You write from the figure, if the lines don't meet, then they don't have any common point. If they either meet or intersect, they could have only one common point. That's it. Make a note of it.
Finish, ma'am.
Okay, one second. One second. But what I have received, the sums are over. I'll get my own storage. I have sums in it. Let me check 1 second. Okay. Now you see, which of the following statements are true and which are false? Give reasons for your answers. So you have to say true or false. If it is true, that's fine. If it is false, why? Why it is false? You have to reason. Okay. Yes, Seshatri, read first one and tell me whether it is true or false.
Yes, ma'am. Only one line can pass through a single point. False, ma'am.
False. Very good. Correct. Why it is false?
Ma'am, a point consists of many infinitive lines. Ma'am. We can draw
Through
infinite
that point, we can draw infinite lines, isn't it? We can draw how many drawing lines we want, we can draw. So this is false. Very good, Seshatri. Keep it up. Next, Rehan. Yes, Rehan.
They are an infinite number of lines which pass through two distinct points.
Mm.
It is true, ma'am.
It's true. Oh, Seshatri, what do you say? Rehan saying is true. Is that is true?
Ma'am, true, ma'am.
Actually, it is not true. It is false. It is false. Why it is false? See, through 2 points, see, through 1 point, we can draw infinite lines. But through 2 points, we can draw only one line. Okay, only one line can be drawn through 2 points. Okay, this is false. Okay, next. Next, Rehan, tell me. True or false?
A terminate line can be produced indefinitely on both the sides. Ma'am, it is true, ma'am.
Very good. Yes, it is true. Yes, if the line is given, that's all. But if you want to wish to extend either side, yes, you can extend how much you want. Yes, it's true. Okay, Seshatri, what about fourth point?
If two circles are equal, then their radii are equal. True, ma'am.
Yes, two circles are equal. Obviously, the radius or must be equal? The radii is plural of radii is plural of radius. Must be equal. Yes. Yes, Rehan. What about fifth one?
Fifth one. In the following figure, if AB equal to PQ and PQ equal to XY, then AB equal to XY. That is following. True, ma'am.
True. Very good. Because this and this are equal, and this and this are equal. Must be this and this must be equal, isn't it? Obviously, A is equal to B, B is equal to C. So you can say A is equal to C, isn't it?
Yes, ma'am.
Yes, that's it. Okay, make a note of it. If it is false, reason it. Okay, why it is false. True, no need, but false, you have to give reason why it is false. Copied?
Yeah.
Okay. This one also. Give a definition for each of the following terms. Are there any terms which need to be defined first? What are they? And how might you define them? Just you explain what, yes, Seshatri, tell me what are parallel lines?
Parallel lines means the difference between the both are equal, ma'am.
What are equal? The distance. Yeah, the perpendicular distance, always constant, not equal. You should not say that way. How do you define if two lines are parallel? How far you extend they don't meet? Rendered 2 points you can give. 1 point is how far you extend they don't meet. Next, what you could say, the perpendicular distance between them is always constant. Wherever you measure, wherever distance, it will be the same throughout its length. That's all. 2 points you can say about parallel lines. Rehan, you tell me, what are perpendicular lines?
Ma'am, two line P and Q lying in the same plane.
I don't think so. Perpendicular lines. They are coplanar lines. Coplanar means they lie on a same plane or called coplanar. Okay, I'm asking about perpendicular lines. Is Seshatri?
Ma'am, perpendicular lines.
Ma'am, perpendicular is from right angle triangle, ma'am.
Very good, very good. The angle between two lines is 90 degree. Then the angle is, the lines are called perpendicular lines. If the angle so this symbol is denoted to mention 90 degree, L1, L2. Okay, so which implies L1 is perpendicular to L2, isn't it? So I named this L1, L2. Here L1 is parallel to L2. Here perpendicular. That means the angle between the lines is 90 degree. Okay. Yes, Seshatri, what is line segment?
Ma'am, a line meets up at the both sides of the line or meet up a point is called line segment.
Both the ends are terminated. A line has got end points, isn't it? If a line has got a end point, if there is a end point, A is an end point of that given line and B is another end point, then this is called, AB is called line segment. Okay, that's it. Okay, what about radius of a circle? How do you define radius?
Ma'am, center of the circle point, that is called radius.
Center, you named already the center point. The point which is fixed to center of the circle is center. Then how come you rename again it as radius?
Ma'am,
No.
this is the first stage to form a circle, ma'am.
See, actually, there is a fixed point. There is a fixed point. I name it as O. And there is a moving point P. Okay, the distance between, so this is fixed point. Fixed point, and this is moving point. Okay, see, actually, definition for circle is about the fixed point, the moving point, it moves. The locus of the moving point is called circle. The path traced by the moving point is called circle, and the distance between the fixed point to the moving point is called radius. The distance is called radius. Okay, guys, I'll show you. I would like to show one animation thing so you will have a better understanding. Wait, I'll show you. Okay, this I name it as, this is O. This I name it as O, center of the circle. What happened? It's not changing.
Your screen is not visible, ma'am.
Visible. Oh, I'm sorry. Wait. I'm sharing my screen. Wait a minute. Yes. Now I hope you could see my screen. Yes?
Yes, ma'am.
Okay. So this is center of the circle. And this is point P is a moving point. Okay. Okay, now what happens? This, okay, now, oh, you can, no, this is wrong. Wait 1 second. How do I change it? No. I can show trace. How do I show trace? It comes some tracing. I don't know. It moves actually. It's not moving. Mm. 1 second, guys. 1 second. See, now you see. Can you, guys? You could see it,
Yes,
right?
ma'am. Yes, ma'am.
Yes. So the locus. Wait, I just. Okay. The length, I can't reduce the length. Wait us. Okay. Okay, it's fine. See, now you see the locus traced by the moving point is circle. The locus means the path. That's it. Nothing else. Okay, locus is a point, is nothing else. So the distance between the center to the moving point is called radius. Okay, that's it. And yeah. Okay, that's it. And the square. What is square? Square is a four-sided
Equal.
closed figure, and it is all sides are equal. The properties, you know, right? It's a plane figure or 2D figure. So these are the ways you can define. Okay, square is a plane figure. All 2D figures. 2D means two-dimensional figures are called, or all plane figures are called 2D figures. Plane figures are two-dimensional. Null figures. Name some two-dimensional figures. Yes, Seshatri.
Ma'am, rectangle.
All see
Then-
rectangle, square, triangle, circle. Huh? What is that? Pentagon, hexagon,
Ma'am,
nanogon.
all the shapes,
All these are all called trapezium, kite, everything or 2D figures or plane figures. Okay, make a note of it. Yes. See, that's it with the Euclid's division geometry. Please go through the topic and do all the sums one by one, finish it off. If any doubt sums are there, do let me know in next class. I'll explain. Okay.
ma'am.
Okay. Once copied, you may leave the class.